a number of different compounds within it. It is also capable of sustaining life and also for leveling landscapes. Can anybody guess what sort of formula I have here in my hand? What is it?
Water!
It is indeed dihydrogen monoxide water. Yes, it is. Water which is capable of sustaining life and cooling large land mammals like the elephant. Also dissolving the many sort of compounds you might be enjoying out here today at the festival. One of my favorites is sweet tea. But also, nothing else excels over time for this compound in its capacity to level landscapes. So talking about water out here, how much water do you think we have in this world that we can use and enjoy? A lot. Okay. Give me a percentage, like out of 100%, out of a pie like this, how much of that pie do you think we can use? This much, this much, this much. How much? 40. He says 40. 40 would be about, yeah, there. Okay. Well, anybody, any other guesses? All right, we're going to explore the amount and location of the water resources here. Let's say, folks, have to get all my equipment out. Let's say, folks, that I have just captured all the water on Earth, and it is right here represented in my kit. So, of all the water on Earth, well, maybe before we get into this, we need to take a little trip in our heads, right? We're going to close our eyes and imagine we're in a big hot air balloon going way up high in the sky and looking back down at our Earth. What sort of colors would we see? What color would you see, young sir? Green, and what would the green be? Grass and trees, all right. And what other colors might we see? Blue. Blue would be what? Water. And what else? What are those white things up there? Clouds are the white. Also at the top and the bottom of the planet, the white would be snow and ice. All right, and one other color that I'm looking for here, looking back, brown. What would the brown be? Okay, bare dirt, not a lot of vegetation. So, let's see, bare dirt like deserts, clouds and ice, and we have green with vegetation, and we have blue with water. Every single color you just described has a relationship to water. The brown, hardly any water. The ice is frozen water. The clouds are water vapor. And the green, because the grass wouldn't grow without water. And then the blue, of course, is water. Oh, by the way, I forgot to say, this is an interactive presentation. So, with that in mind, this is representing all the water on Earth, and I tried to measure it out to scale as best as possible. So I have here in my hand the largest amount of water on Earth, and it is blue. What did we say the blue was? What kind of water? Oceans, and oceans have what in it? Salt water. Can we use salt water? We could use it for, let's see, recreation, navigation, power generation, and some medication. But other than that, the largest amount of water on Earth we don't really have much of a use for. I shall set it aside there. That makes all of this fresh water, which is a good thing. We like fresh water, right? Yeah. Where would we find the most fresh water on Earth? Anybody? Not all at once. Not in the Great Lakes. Where else? The most fresh water on Earth. Think back to how much of the Earth is covered by that color white. Snow and ice. And where would we find the most snow and ice?
Arctic.
In the Arctic and the Antarctic. So most of the fresh water on Earth is actually captured in ice. We can't really get to it. Next we have that color green. What did we say the green was?
Yeah.
Grass and trees and you and me. This is the water that's in everything that's living. The grass, the trees, and you and me. How much water is in your body? A lot, he says. As a matter of fact, between 70 and 80% of our bodies are made up of water. From the tips of my toes all the way up to about here. That much of my body is made up of water. I'm using my water. You're using your water, and her, and the trees, and the grass, and the squirrels, and the raccoons. Everything's using its water. Can anything else use that water at the same time? No. So this is unavailable. So out of all of the different things that I have measured out here, I have probably been too extreme in measuring out this amount of water. This is representing all of the available fresh water on the planet Earth that we have for use. Look closely, because it's just a drop in the bucket. So, how would that measure out? What do you think those percentages are? Again, not everybody all at once. Not a whole lot. Well, as it turns out, I have measured out the amount of water and its location on Earth on this. What is this? It's a measuring stick. What kind of measuring stick?
Yardstick.
It is not a yardstick. It is a meter stick. So if I had 100% of something, I can measure it out using centimeters on this stick, which is what I have done. 97% of all the water on Earth is salt water. Again, good for recreation, navigation, power generation, and some medication. But other than that, not much use for us as people. 3% has fresh water, but most of that is locked in ice. 2.4. You're all doing the math in your heads, right? All right. 0.6 is in that green, in the grass, the trees, and you and me. Again, that's locked up, not available for use. Out of all this water, that red end of the stick is all the water you will ever see or use in your lifetime. 97%, 2.4%, 0.6%. Ready for this number? 0.03% of all the water on Earth is available fresh water. Now, fortunately, that happens to look like this. It's a map. It's a map of all the fresh waterways on Earth. And indeed, you'll notice there is an abundance of fresh water in many places, and other places where there's a lot of brown, a lot of desert. Well, you do? Okay. Well, we happen to be right here in the Great Lakes. What is the closest river? Do you know where the river is? Everybody point to the river. All right, and what river is that? No, it is not the Mommy, St. Joseph. There we go. All right, St. Joseph River, and it goes to the Great Lakes. All right, and over here, we have another lake called Lake Baikal. Now, everybody hold up your hand. I'm going to take all the available water in the world and divide it into fifths, into 5. The Great Lakes represent 1/5 of the world's available fresh water. 1/5. Another 1/5 is over here in this lake, Lake Baikal. 2/5. 2/5 of the world's available fresh water under the care and control of less than 1% of the world's population. So as you're walking around here today, think of yourself, count 99 other people, and they all have to share that other 3/5. That other 3/5 means the rest of North America, all of South America, all of Africa, all of Europe, all of Australia, and most of Asia are sharing the other 3/5. And again, all of those with huge bands of little or no water in the deserts, in the desert regions. Now, keeping that in mind, that we are fortunate to be within the watershed of 1/5 of the world's available fresh water, how much water would you expect to be out here in Allen County? Any guesses? Is it going to look really, really wet or really, really dry? Maybe half and half? Split like that. Okay. Well, I happen to have another map. I like maps. But then again, I am a geographer. And on this map, we happen to have a map of the waterways of Allen County. Believe it or not, oh, and there goes the wind. Believe it or not, folks, we have 2,000 miles of waterway in Allen County. That's enough waterway mileage to go from here to Denver, Colorado and back.